Safety first. It is a saying that is used all over the world. According to the study done by Purdue University and Tippecanoe County, the importance of finding a solution for mobility safety has been recognized by both the state and county due to costs on economic and human lives. The Campus Safety Committee at Purdue University requires an evidence-based model that can decrease mobility-related accidents, injuries, and near misses that helps improve the safety of campus mobility. The model must be economically viable and technically feasible for Purdue. This means that the design cannot compromise Purdue financially, and the technologies used by the solution must exist. The model will be tested on its ability to be aesthetically pleasing, demonstrate a clear enhancement of mobility safety, is usable by a vast majority of stakeholders, and is reliable, safe, maintainable, and sustainable. Among all the ideas, we chose to install a bike fence which can separate bike lanes and pedestrian lanes in order to decrease the possibilities of crashes with pedestrians and bikes. With the addition of the bike lane, pedestrians will cease to cross the bike lane at non-intersecting points as there will be something preventing them from doing so. In addition to the bike fence, there will be a sensor which can detect motion so that the pedestrians will be alerted when there is a bike coming. In order for the pedestrian to know that there is a bike incoming, there will be a strip of LED lights on the ground that will light up red, as well as a buzzer that will sound when a bike is coming. Including both forms of warning signals was important, as it will assist those who are deaf or blind as they cross bike lanes. We began our design generation process by brainstorming. For brainstorming, we sketched several ideas on the whiteboard in the classroom. Then we deliberated on which designs we believed best fit the criteria given to us by the client. Once we determined the 3 best designs for the project, we made real-life models out of cardboard. After we created metrics for the criteria in order to select the best design out of the 3, we chose through a weighted decision matrix. The results we gathered from surveys and test trials are shown here. At the top, the criteria are scored and are normalized based on a scale of percentage and a scale of 1 to 5. On the left-hand column below, we have our gathered raw data scores for aesthetics and safety present for each solution. On the right-hand column, we analyze the scores by using histograms to see where the range of scores fall on. We believe this will reflect how people believe each design will perform in the particular aspect of the design. After applying our weighted decision matrix to the 3 designs that we chose to continue on with, our team observed that there were 2 designs that received the same score, these 2 designs being the sensor poles and the sensor warning. However, because we are aiming for future development of a campus mobility ecosystem, our team made the decision to combine the bike lane and pedestrian walk lane intersection sensors with the bike lane fence. This would combine the most cost-efficient method and the top-ranking method to create a synthesis solution that can synergize well with one another.
Here is our working prototype. This prototype represents one side of this intersection. When the bike passes through the sonic sensor as shown, the buzzer and 2 red LEDs that represent the light strips on the pedestrian crosswalks will trigger. The sonic sensor is positioned just before the pedestrian intersection in the bike fence. It allows ample time for the buzzer and lights to trigger, even for a faster moving bike. As seen in the code, the sonic sensor's input controls all outputs for signaling and controlling pedestrians. The sensor also has a specific threshold value to ensure that the sensor does not trigger for movement across the entire bike lane. This ensures the safety of the pedestrians walking and allows for a better system.
We believe our design has the potential to enhance the safety of our peers and demonstrate the use of technology in regulating traffic and pedestrians alike.